Red light's going. It is now the 26th of May. It is, or March 5000th in the coronavirus timing, and we're here for Dallas Personal Robotics Group, Robot Builders Night Out. My name's Carl, the current president of this soiree. And tonight, we're going to have our usual just kind of round table exercise. We'll go around and see what everybody's been doing, have our show and tells. And with that, let's kick it off. And if you guys are open, since I've already got the screen, I am happy to start this off if there's no objections. I have something to show and tell. If I can make my computer work correctly. So where's the present now button? Okay, so what I'll do is, I said I had it ready and I lied, didn't I? I lied. Okay, so you guys remember this? Oh, I'm not presenting it. Our screen, this one. Okay, if you guys remember this little contraption, right? I have this robot. And it's got the Raspberry Pi on top, and it's got Arduino Mego on the bottom. Well, it turns out that I had some progress last week. I figured out that whenever I would hit the power button, or I would hit the panic button to stop like an automatic driving routine, I figured out that the thing would kind of like crash the Arduino. So it turns out that I traced it down, and I can show this oscilloscope trace. Now what you see here on the bottom is the trigger. This is whenever I hit the panic button, and it just stops the motors kind of abruptly. And anybody care to guess what this green line is?
The power supply.
That is 5 volts here, and then it drops down to 2 volts for about 30 or 40 milliseconds. Before it goes back up to 5 volts.
Yeah.
Wow.
So how well does the Raspberry Pi tolerate that? Not very well. It reboots immediately.
Well, that'll also brown out the Arduino too.
Arduino, yeah.
Oh no, well, if the Arduino was on this 5 volts. So that's the funny part, you see. The Arduino survives no problem, but it's on its own regulator. So what that tells me is that the regulator that I have used to power the Pi cannot handle input transients very well.
Probably need, yeah, a capacitor or something.
It's a messed up. So I've narrowed it down, and because it is such an egregious kind of thing here, that's a major dip. Because it's such a major egregious dip, I decided I'm not going to try and patch that in software. It's not happening. I'm going to work on the power supply, but that's very deep in the robot. So for now, I'm going to live with it and just power the Raspberry Pi with a separate battery.
Oh.
Ah.
So I'll just plug the Raspberry Pi into this guy, and life goes on until I get around to feeling like doing hardware again.
Yeah. I actually used one of those battery packs for the joystick, just to plug it in.
Yep.
And for low currents, they are horrible. It's like 5 volts with 1 volt of peak to peak ripple on it, and not great for analog joysticks by any means. So I went back to just a straight lithium ion battery, but without the booster in it to get it up to 5 volts.
But that might just be because it's lightly loaded, right?
Yeah, that's true. It could be.
I didn't look at how clean this guy was, but I did notice that it powered the Pi just fine.
Huh. Yeah, that
kind of reminds me of
long. I was surprised.
It kind of reminds me of a problem I'm always having, as I've been playing around a little bit with this what they call the Adafruit Cricket Python and so this is my little robot that has one of these tiny USB batteries in it. The problem with this one was that there wasn't enough current being drawn that the battery would shut down.
Yeah.
So I ended up finding a circuit online that looks like that. You can see that. 2 transistors, 2 resistors, and a capacitor. You can imagine what that is, an oscillator.
Yeah.
And every second and a half, it does a pulse across a 22 ohm resistor, which does enough of a pull on the battery that it actually keeps it alive.
Keeps it awake.
God, the
Nice.
stuff we have to do, right?
It's a pain.
Yeah.
Darn power, but it's critical. Tips and tricks.
Oh, yeah.
Okay, so the next thing I had to show here is that you'll notice that there is now this kind of extra lights on the robot here, these 7 little lights. So I managed to add a NeoPixel to this thing. And what I'll do here is I'll reboot the Arduino so you can see what happens on its self-test when it wakes up. So I'll click go, and there it is. You can see it checks out all the colors of all the lights, and then it goes to its normal stage. Woohoo!
Yay! Lights.
You know you're building a Cylon there, right? You know, that's not
That's
how Cylons get built.
That's another thing. I think, I mean, in the future, it'll need to have a nice little diffused plexiglass so that it's not clearly distinct lights. Because, I mean, the quality of these, they're unfiltered, is so harsh compared to this nice, smooth, round button thing. But now you see what I can do is I also wired it up so that on the joystick, if I hold the select button and push the left joystick in, click, you'll see that it now turns off the command, so it no longer is sending joystick commands up to the robot. It means I just can drive it locally. So, and then if I do the same thing and I click the right joystick, it flips the mode over so that now the robot on the base ignores whatever the Raspberry Pi is sending down. Or I could put it in this mode and turn both off, and it just doesn't do anything. So I have
got a robot like that.
Say what?
I have
You got a robot like that?
Yeah, it doesn't do anything.
Major design constraint, right? Okay, so the last little demo is now that this is a VNC window, and what I'll do is I'll start the Donkey Car software. Now what we're looking at here on the oscilloscope is the bottom trace is the 20 millihertz cycle that's always running in my robot. That's just the heartbeat. Everything runs on a 20 millisecond interrupt. The top trace is the commanded SPI data line, or clock data line, I think, from the Pi down to the Arduino. So if I go down to this window, this VNC shelled into the Pi, and I start up Donkey Car, you'll see that at some point here, the serial communication lights up. And whenever that happens, a little yellow light comes on and says, you got an SPI port that's active. So what happens if I kill the SPI port? Little yellow light goes off. So I can
Thank
now...
God for those lights. I get a suggestion for lights. If you take a piece of plexiglass and you use some 800 grit sandpaper and just polish the back with 800 grit and put that in front, it'll take off the glare.
Yep, I think you're right. Yep. One of these days, I'll get there. Absolutely.
Yeah, of course. It's better to see the light, though.
It's on your creative backlog.
Yeah, it's so short. But anyhow, that's what I had to show. So unfortunately, there's no video of a trained donkey car driving itself around, but the hardware and software is all ready to go now. It's just a matter of little time and to go train it and see if it actually drives itself around. But I got the scales and the gains all set up so that it should work. It should be. It's supposed to work, so it should work. Why wouldn't it
Hey,
work?
Carl, on the Donkey Car software for your joysticks, did you put in like a lower value? You know, it's kind of like I guess out of the joysticks, it's a floating point value 0 to 1, I guess. But you can actually say where kind of like the 0 point is. So
Between
maybe, you know, out of 255 counts, like 30 some counts before your wheels even start to spin. And I wondered
whatever
if you did
resistors in
that,
it.
you had to push them, and there's a very small band that, you know, it's like from nothing to full, and it just may expand that band out of actually pushing the joystick and having your platform move.
Sorry, Ray, you're really chopping up. Could you restate your question?
Oh, okay. On the Donkey Car software, there was an option to put in like a, you know, for the range for like, you know, left motor or right motor, what a minimum value was for PWM, you know, off of the joystick. So you could, you know, say you're with very small values of PWM, your motors may not even move. And so you could figure out what that value was just by pushing your joystick and looking at what the value was, and put that in as a minimum value. So when you're not pushing the joysticks, it actually starts at that value. So it would actually expand the range of control on the joystick instead of having like a big dead band at the bottom and then, you know, pushing it just a little further. It's like your motors are on full speed or something.
Oh, Ray, I did something kind of similar to that, but I automated that because I've got motor encoders. I actually have a little starting routine that looks and sees if a value of a variable is a none, because I'm in Python. And if it's none, it'll keep track of the encoders. And as soon as the motor begins to tick over and the encoder starts to come back, that sets its minimum value.
Yeah.
So it's basically automating what you're talking about.
Yeah. Doug, I don't know if you remember it, but that was like one of the parameters that you could set up in the Donkey Car code. And I'm assuming, Carl, you were using the same code.
Okay, so to answer your question, I've started with the about a month old now Donkey Car 3 base.
Yeah.
Uh-huh.
And what you're talking about, I think, Ray, is the function that maps from a user's joystick control all the way through the different software parts till it hits and turns into PWM.
Right.
So by design choice, I didn't like the various crazy mapping things. They seemed reasonable, but I didn't like them that were in the Donkey Car.
Yeah.
So I basically bypassed and hacked past all of them. So because I want this to be scaled to my robot base, and as far as I can tell, the Donkey Car just takes numbers on a range of 0 to -1 to +1. It doesn't care.
Mm-hmm.
Okay, so what I've done is, because of that whole deadband issue and the range of motion in the joystick, because that's really peculiar for kinds of dorky, cheapy controllers that I have, and the particular robot base that I have. So I have my own kind of mapping functions that are built from this, and they work pretty well, both for the Club Car Donkey Bot that I have, but also for that 4 Mecanum wheel hover sim that I'm working on.
Yeah.
So the same motions on the joystick give similar response to the physical robot.
Uh-huh.
So what I do is that I have that mapping function that gives me the kind of granular, the kind of range of control, range of motion, range of control that I want, behavior that I want. And then it basically maps the joystick and button options. It matches that to a velocity command, which is ticks per time.
Oh, okay.
So all I have to do is I map and I scale that ticks per time from -1 to +1, which fits in the Donkey Car's domain space. And that's how I'm planning to do it. So that, and I mean, in reality, it turns out that, like, I think the one I have over here I just showed you, its range is ±127, whereas the 4-wheel Mecanum one that I have is ±100. But whatever, a range is a range.
Right.
So I define the range for each robot. I have the deadband that is for that robot, and then the controls are designed to give similar behavior no matter what robot I'm driving.
Yeah. Oh.
And then because these controllers are so cheap, it's easy to buy 2, which is good because when it loses sync with one, you turn it off and turn the other one on, and it works.
Yeah. Is that an indicator to change the battery or something, or what?
It's an indicator to change the firmware. I just can't tell if it's the stock Sony, whatever firmware is built into the dongle, or if it's the firmware from the open source library that I've hacked on.
Oh.
But one of those two things has got a robustness problem. it loses physical layer sync as best I can tell,
Yeah.
depending on how you cycle power on the Arduino mainly in code. So it seems to be some problem between the Arduino and the dongle, the RF dongle for the joystick. But still, I really recommend these because they're inexpensive, and you can get lots of spare parts from lots of places that are compatible. And it's got so many button and control options that, I mean, as a UI, you're just not going to run out of buttons if you need them.
Oh yeah.
The only problem is keeping track of what does what.
Yeah.
That is a problem. That's why I didn't drive this around. I spent a little time documenting things so I could remember what in the world it was supposed to do.
Ooh.
I probably
What I did.
I was running around. How much did that PS2 controller cost?
The Lynx Motion version off Robot Shop is about $25.
Okay.
And then you can find unbranded knockoffs on AliExpress for 10 or 12. And that's controller plus adapter board plus RF dongle, like the one I slacked last week.
I got you. Yeah, I've been trying to use the Xbox One controllers because turns out there's two kinds of those controllers. One of them does Bluetooth, one of them doesn't. I know the difference now. I've got both. They're usually about $50 a piece. So, but it doesn't require another dongle on it, right? Because we'll talk Bluetooth, right? But,
oh yeah, Bluetooth, right.
Yeah, it'll talk Bluetooth. You know, for 50 extra bucks, I could buy 2 of those and plan for having a dongle. I think that's probably a better deal.
I mean, it's not bad. It's not a huge dongle. It's not a small dongle, but it's reasonable.
Yeah.
And then it comes with an adapter board.
A big dongle.
Dongle talk. All right. Dongle jokes never end. There was the guy who managed R&D at Nokia when I was there. He had a band. Well, it was a company band, and we were doing mobile phones, right? So we always had these dongles to connect to the phones to program them. So the band was called Donald and the Dongles.
You know, I'm leaving that joke alone. I just got to leave that alone, man.
With that having said, I think I should stop and we should move on. So I think, Ray, you were next to become visible. So would you like to
Sure.
chatter next?
Sure. Okay. God, having something. Okay. Yeah. So my wife and I were getting stir crazy. So just wanted to get out of the house and go somewhere. And I've been looking at these hydrostatic transaxles for a while. And let me see my entire screen. I'm going to do my entire screen. Share. Anyway, so we drove up to a place called, can you see that?
Yeah.
Staten Inc. He makes motorized bicycles, and he's been doing it, I don't know, since like the mid to early 80s. Anyway, this unit, let's see if I can get this to open up. Okay, come on, you opened up a second ago. There we go. You know, it's V-belt driven. It's got a fan. This is it's just a disconnect if you need to push the thing to disengage the rear wheels. And this is basically how you control it. This is a lever for forward and reverse, and this is a lever for the brake. And this one was a little unusual. It had bigger axles than what I wanted. They were 1-inch axles, and
Wow.
all the stuff I have is 3/4 inch. So I had to buy hubs and wheels for it, and which was a little extra money, but it's just very easy to control a mowing platform with those versus you know, it basically just takes a servo to push that lever up and down, and that's your forward and reverse. The further you push it, the faster you move. And I also got these were they're just transmissions for self-propelled mowers, and they're pretty much kind of an on-off thing, and if you put 2 back-to-back, you can have forward and reverse speeds. And they were dirt cheap. They were $4 each, so I got a bunch. Got 4 of them. So that's what I've been doing. Took a drive up to Oklahoma City and got all this stuff and saved about $100 in freight. Plus, got to meet the guys.
You saved $45.55.
Minus gas.
Oh yeah. That's about what they cost on eBay.
Wow.
So what do you do with them now?
Well, I was actually gonna, instead of using DC motors to let's see if I can get out of this here. Instead of using DC motors to push the mower platforms, I was going to use either mechanical or the hydrostatic one. One of the nice things about the hydrostatic ones is I can get probably at least 10 times the amount of force out of it. So about 200 foot-pounds of force on an 18-inch wheel versus maybe at most 20 on a 10-inch wheel that you could stick on a wheelchair motor. So quite a bit more force to push the platform around.
Ray, does that require a separate pump, or is the pump built in on the back side of that fan?
Yeah, it's a let's see what it is. One's a variable displacement. I think it's a variable displacement motor and a fixed displacement pump. So it's self-contained and it has a differential in it. So the 2 wheels, you can actually steer with it if you put 2 brakes on each of the axle shafts. And if you stop one, the other one will spin, and vice versa. So you can turn by using brakes. So it's I was just going to use like whatever it is. Is it Ackerman's steering? I think that's what it's called. Where you have the wheels that kind of like a car. They turn side to side.
When we built the outdoor robot, the J-Bot robot, I don't know if you remember, that originally was supposed to be a small scale version of a larger vehicle, which was going to be entered in that NASA challenge. And the larger vehicle, we were going to power from those very hydrostatic drives. We'd actually done a bunch of research. So, cool. I hope we do something cool with it. I also occurred to me that this would be the right way to make a large-scale balancing robot, because you drive the thing forward and reverse.
Oh yeah. I guess just as long as it could spin its wheels fast enough to keep the pendulum up, I guess, right? Inverted pendulum motor. Anyway, so that's what I've been working on. Yeah, for the most part, the mowers, I don't really need variable speed. And if you think about it, when you mow, it's kind of like a tractor. You have a throttle, you push the throttle up, and you proceed at whatever speed you want to. Usually a fixed speed. So thought I'd give it a try. I haven't, except for Donkey Car, hadn't really done anything where everything else was differential steer or 2-wheel, 2 motors kind of thing.
Let me be sure I understand. You drive that unit with an electric motor and a seatbelt?
Well, it's it's going to be a gas motor, gas engine.
But that motor can then always run at a constant speed and drive the hydrostatic drive, and then you speed up and slow down and reverse and so forth with the drive itself, not with the gas motor.
That's correct. Yeah, that's
Very
correct.
cool.
You're breaking up, Dave. I can't hear you.
That's because Doug is making all that noise.
Yeah, Doug is making a lot of noise there.
Must be
That's
probably in popcorn or something.
Eating a really crunchy salad.
I just said very cool. So.
Oh, okay.
Okay, Doug, I've muted you. If you want to say something, you'll have to unmute yourself. When he comes back, we'll let him know. All right, so Murray, how about you? How's it been going down under? Or up on top from your point of view?
Up on top. Yeah, we're on top, man. Well, as everything, it relies on shipments from afar, and I got my shipment finally. One from Pololu and one from Robot Shop, and I can't remember where it was. Now, I've been working on a couple different things, but the thing I've been focusing most on is this Raspberry Pi to Arduino communication. And I have been using an Arduino Micro, and that was working, but I really wanted a 3-volt processor, so I ordered one of these Arduino Nano BLE Sense, which is their fancy version that has lots of sensors, and it's a 3-volt processor. And I spent at least a day or so on this thing before I found out that the wire library that does the comms hasn't implemented the slave functionality on I2C. They just didn't bother doing it. And I had to dig in the forums to find this out. So I've got this nice little processor here that's useless for my purposes. And I complained about it, but nothing's going to change. So I've got the Micro here, which is the 5-volt. But what I ended up deciding to do is I'll unplug this thing. So I've re-implemented it, but instead of using an Arduino, because I'm pissed off at Arduinos, I ended up using an Itsy Bitsy. Now, this little Itsy Bitsy is a 120 megahertz processor. Lots of pins. It's got, I think, 5 or 6 native analog digital converters, AD converters. It's got like about another 10 or 15 pins for digital, and it's tiny, and it works. And so I've re-implemented and changed the code a bit and managed to get this working really well, and the performance on it is fine. It runs, if I don't put any delays on the Pi, it basically can make all the changes and get all the data off here for my analog infrared sensor, my digital infrared sensor, an LED, and a button. That's my test bed. So this is actually functional and works pretty well. But in the process of doing this, I did also get another object in the mail, which is this, which I'm quite pleased. I think David Anderson might be interested in this. This is get it the right way up, it's an Arduino Yun, which Yun in Mandarin means cloud. Now this combines a regular Atmega processor, an Arduino, with a specialized Linux chip that runs OpenWRT Linux on the same board. So this is actually 2 computers on one. They communicate over a bridge over serial. And I've managed on the Linux side, which is a little bit broken, but I've managed to install Python 3. It comes with Python 2, but I've managed to put Python 3 and most of my robot operating system on it. The Arduino side, I've managed to get running with this slave processor, and it works fine. So in theory, as David has suggested, I could just dump my Raspberry Pi. I could, in theory, use this. It's a little bit weird because the Linux processor and its input-output isn't the same. I don't have all the pins and everything like that. And its I2 processor, I mean, there's an SDA and an SCL pin on here, but it's actually the SDA and SCL pins of the Arduino. And I haven't quite figured out how that works yet. But it's a really interesting processor. I'm quite pleased with this.
Mary, that OpenWRT, is that the same Linux that we run on our routers?
I believe so. Yes, it is. Yeah, it is. So I would say that the Arduino Nano BLE Sense, if you're going to use it in a slave, forget it. But I'm quite intrigued with this thing. In fact, I leave it running all the time because I feel bad shutting it down. You can tell that it's kind of alive. It's this little animal. And I've mounted it on this nice big piece of Delrin, and it lives all the time now. And so if I can figure out how to get it onto a robot, I will. But they're pretty cool. It's a really nice little processor. And the fact that it's got a bridge so you can do stuff in Python and then send slave commands across. I haven't quite figured out how the bridge works yet. I haven't got that working. But what's it called? I2C detect command on the Linux side can't see the I2C bus of the Arduino, but I think it might be able to, but I don't know. I think it actually only communicates over serial, which wouldn't be a problem because that's what my solution was anyway. So, but I'm going to continue to investigate this. And then the only other thing I've got to mention is that the front of my robot is as I've mentioned before, kind of a stolen design from David's SR04. And I'm going to take this off and rebuild it. But what I'm going to do is actually mount the itsy bitsy processor actually on the bumper itself and basically make the bumper into a sensor, because that's the idea, is that you would connect up with the itsy bitsy and get all the data of the bumpers, the switches, the infrareds, everything would come off of that onto this basically self-contained bumper. And then you just communicate with the itsy bitsy processor, and the bumper and all the infrareds and everything in the front of the robot becomes one sensor. And that's kind of the idea with that. So that's coming along, and it seems to be working pretty well. And I'm going to rebuild that bumper so that there's actually room for it on for the itsy bitsy on the front. So that's about it.
That's pretty cool.
Been kind of busy.
I put some links in there. I think they might be the devices you mentioned. Is the Arduino Uno, is there a newer version of that? Because on the Arduino site it says retired.
Yeah, though I should mention the one I have is called a Rev 2. It's the new one. Yeah, they have an older model and a newer model.
All right. It'll be neat to see that. I mean, to have them bridged like that with some libraries to leverage, that sounds pretty good.
Well, the nice thing is you get all the advantage of the Arduino and its I/O, and the idea of having that sort of separation of concerns of having, like I wanted to, having a sensor that is all of my front bumper sensors and infrared, everything on one, and that would effectively be the Arduino on here. Now, I can do that with the itsy bitsy, but if I want to take it to the next stage, which David's pushing me towards, which is to dump the Raspberry Pi, I could do that with this. I'm happy either way. Actually, I like the Raspberry Pi, but I've got lots of stuff hooked into it, so it's like I'd have to dump all that. I think I'd do that on a different robot. Robot number 3.
It can only take you another week at this rate. My goodness.
Yeah. I did get all of my my hubs came in now, so I've actually got all 4 of the mini, what are they called, micro gear motors with the Mecanum wheels and the hubs. So I could, in theory, start working on that robot, but no, I think I'll hold off.
You get there.
I'll get there. I probably should mention I start a new job. The last day on my job that I'm in right now is this week. I start a new job in a couple weeks, and I don't know what that will do about my availability for these meetings. But
midday.
Yeah, I don't know. We're going to still be working from home as far as I know, but I'm not sure. What's that, Ray?
I said this should take priority, shouldn't it?
Well, it would if it was up to me, but I got to pay bills.
Oh dear.
Details.
Ray has a check. Ray will send you a check.
Okay, as long as the check's in the mail.
Checks in the mail. There you go.
Yeah. Okay. Cool.
All righty. So let's move down Hollywood Squares here. So Mr. Ackley.
Oh, nothing much to report. Just mostly full-time caregiver.
No chance to work on the simulator?
I've played a little bit with it, but I'm probably making about as much progress as you did.
Okay. Well, I'm trying to feel good about my progress, so let's give you the benefit of a doubt. Way to go.
Oh, I just couldn't pass that one up.
No, not at all. Right. Somebody's got to take it ahead. Okay. All right, moving on. So, Mr. Harady, I put you on mute, so you'll need to unmute if you want to make scraping sounds.
Did you finish those crackers and cheese or what?
No, I haven't even been in the room. So let me, I wanted you to go back to my robot. Oops. I'm going to show a few things. I came this close to being able to show you this running on the line following course. I've got, let's see if you can see this. Maybe not. God, it's hard to get it under the screen. Now the robot is essentially completely wired up. All right, so it's go. I have the biggest thing I'm been obstacles this week is trying to figure out how to do things in MicroPython. But I now have the serial link going back and forth, and essentially the program now reports the center of the line. Okay, so that's not me, guys. I don't know who it is, but so it's the center of the line. But I have a couple of techniques I thought I would share with people. I had a module, which was the translator module. Not translator, what am I going to say? Level shifter. The level shifter module. Can you mute everybody, Carl?
Yeah, I can hear you.
Okay, now, so anyway, I didn't want to put it in shrink wrap because I wanted to be able to read the pinouts on it all the time. So I thought of a technique that is kind of clever, or at least I think it's clever. You may be familiar with this stuff. And you ever seen these pouches, these laminating pouches? They're used by small home laminators, and my wife has one for her business. So it's a possible substitution for heat shrink. And if I can find the camera, why can't I find the camera? Okay. All right, here you go. So here I've taken, this is not one of my boards. This is just a random board that I happen to have around. It was one I was playing with. So what you do is you take a small piece of the material, and it's actually folded in half. So there's like a layer for the top and the bottom. You hit it with a heat gun, just a standard heat gun, and it goes transparent. And I use a dental pick to just run around the edges and seal it. And it's a way to encase your board in a clear plastic and not have to worry about it, so that if it's mounted in your robot, that something will hit it and knock a piece off or something like that. So I thought that was kind of a cool idea. And I've also worked with, this is a piece of good old masonite. It's tempered on one side. Well, I was in a forum looking around a laser cutting forum, and the guy was saying, "Hey, I love this tempered hardboard. How do I, but I can't seem to get it anywhere." And it turns out, so the answers were, well, what it is it's just hardboard that they've essentially put a little bit of linseed oil on and then baked. Well, it turns out you can take boiled linseed oil, which is really thin, and you can coat it. And I mean, it just sucks up into the wood. You don't even, you wipe it on and it's dry. Okay. And it changes the color, but if you feel it, it's a lot slicker. It's more water repellent. And on the back side, which, is somewhat fuzzy, it cuts down on the fuzziness. You can't overcome the texture, but you get rid of some of the fuzziness. So right now, I'm trying to think of it as a post process of laser cutting, but it might actually be a pre-process. Because you know your hardboard comes tempered to a degree, but this really kicks it up a notch. It's a lot nicer
Hey,
material.
comment on linseed oil.
Yeah.
My father-in-law really, I don't know. I think it's his second love. He just adores this stuff. It goes on everything.
Mm-hmm.
But there's this little secret apparently that if you get linseed oil in the rag you use to rub it on and such,
Yeah,
it's that kind of chemical which can like spontaneously combust.
Yeah.
that's right. Yeah,
Yeah.
you gotta watch out
It's
for
a wee
that.
bit flammable.
Yeah,
Yeah,
not just a wee bit.
Everybody now, it's a wee bit flammable. So,
Hey,
you really want to do that before the laser cutter, Doug.
well,
Yeah, oh yeah.
you got to remember that the laser cutter, I mean, you can buy tempered masonite, and it cuts great. The question is you get everything is quote tempered to a degree, but every once in a while you get one that is really good, and it's really nice. And I'm thinking this can take the typical masonite and kick it up to really nice.
Doug, did you bake that linseed oil on, or did you just wipe it on?
No, I'm not using linseed oil per se. I'm using boiled linseed oil. Okay.
Does that chemically alter it?
It does something to it. It's not gummy, it's not thick and gummy. It's more like a liquid. You know, it's real liquid. I don't know what
I mean, if you have boiled water, it's still water, right?
Yeah. No, I hear you.
No, it's something else.
No, it does something
They
to
call
it.
it steam, don't they? Isn't that how that works?
I'm not sure. I know there's a difference because I used to work with wood, and there is a difference. But a boiled linseed oil is a different, basically, I think a different chemical makeup. It does something to it. You'd have to. That's what.
And you baked that on after you wiped it. The boiled linseed oil.
I did
you
not
just wiped it on,
and it just soaked into the wood, which told me that the original wood was not sealed. So now it has a feeling of being sealed.
To answer I used to be a painter. I can't claim to be anymore. I haven't done it for a long time. But the one thing about linseed oil, boiled or not, is that as in many of these oils, there's a solvent involved, and the solvent is what is really flammable. The oil itself will burn, of course, at a certain temperature. But if you were to put boiled linseed oil onto a piece of wood and then bake it, you'd basically be baking off the solvent. And I don't think then it would be very flammable. The laser might set the oil on fire, but it's really the solvent you have to worry about. So if you get rid of the solvent, you'll be fine.
I think how some of that happens with Carl's flammability stuff goes on there is you get some on a rag and you chunk it. Get some on a rag, you chunk it. Now you get a big pile of these rags, and as that thing is drying up and leaching out, it's exothermic. It does cause just a little bit of heat, and enough bundle of rags in a pile can generate enough heat to set it on fire.
Yeah.
And once it starts burning
in
its
the back
own,
of your car, maybe.
yeah. Once it starts burning its own.
It's like your lithium batteries, beware.
Well, it was just crazy because my father-in-law would come, he would paint something, he'd coat it with linseed oil, whether it was linseed oil compatible or not, he would cover it with linseed oil, and then he'd leave back to the other city he lives in, and I'd find this bucket of water with these rags submerged in it. Thinking, what am I supposed to do now? I'll take it out and my house will explode, right?
Yeah,
So
no, just spread it out, put it on the concrete, let the sun bake it for a little bit, let it dry out, you're good. It's the big pile of stuff that gets the problem.
Yeah.
Give it to Doug.
Give it to Doug. He'll make these robots are smoking.
Yeah, I have one other thing that, I don't know how many of you people are using the Arduino PID library.
I looked at it.
I use it all the time. Okay. And I found something that I couldn't really understand what was going on. And then it dawned on me what was going on. One of the things that you have is the set loop. Let me give a second. Let me look at it here.
Set loop gains?
No. Sample time. Set sample time.
Oh, yeah.
All right. Well, you know, how that works in that library is that it loops through your loop. Okay. And every time it hits the compute statement, it evaluates whether a time of the sample time has been exceeded or not. All right. So if you've got, let's say, a two millisecond cycle loop, that means it would go through the loop 10 times. And then on the 10th one, then if you had it set at 20 milliseconds per sample time, then you would actually get your PID value. Okay. So you get that. That's how they keep the timing constant, so that you can you don't have to include the time factors into the derivative and integration. Okay, so I looked at how to do that, and you wanted something that would be loop time insensitive. So I think I've come up with something. You know, my first thought was, well, okay, I'll just you know, time the loop to 20 milliseconds, and when 20 milliseconds is over, it'll go through the loop. If it only goes through 2, it'll waste 18 milliseconds. But that's easy to do. But the problem you run into is that if you're a little bit out of sync with your compute statement, you can actually have to go around the loop twice, or 40 milliseconds before it hits on the second time. Do you follow me? And so because of that, because of trying to keep everything synced up, it's a little bit difficult. So I'm going to share something on the screen if I can see if I can figure out how to do that. Oh, here it is.
I want to see if you're going to show the solution the same as I came up with. Let's see.
Okay. Start sharing. Your screen is sharing. Okay, so I want to go. All right. So are you guys seeing some code?
Yep.
Yep.
Okay. All right. So now my motors are particularly mismatched. Okay, so that's why you're going to see things broken out into left motor, right motor. So what this thing does in the loop, okay, it has a set point. Now this could actually be, I put them here to limit scope. It's not, there's no reason why these couldn't have been globals. Okay, so it goes through, and this is the actual set point or the target value. And if you go up to here, you can see that the motor speed is set at 10, and that's in RPM. So it's set up in 10 RPMs. And then it comes down and it sets this read trigger to false. Otherwise, left and right motor are both set to false. Okay, and it also puts a static variable called the cumulative encoder interval count. And when it comes through the loop, what it does is it calculates the encoder interval counts and then adds them to each of the two motor sides, the left motor and the right motor. Okay, then it makes them the PID inputs. All right, then it reads, okay, so then it does an actual compute on, in this case, it's doing a compute on the left motor. And this read trigger, if the compute actually fires it returns a 1 here, or it returns a true, okay? So if it's true, then you reset the cumulative encoder interval counts to 0, and you send the trigger false, and you just repeat that for the right motor. The way that works then, so as well as you can, you have the cumulative encoder counts between the time that it fired last time and the time it fired this time being used as your set point. I mean, used as your inputs. That actually seems to be working really well. I can drive these motors down to, you know, like three pulses per loop, or 3 pulses per compute loop. Am I being clear?
Yep.
Okay. So anyway, it actually worked pretty well, and this is not, you know, it's not using task-lib that David has, because this program doesn't need it. This is just going to, all this thing is doing is running them. This is a test program for the motors. And anyway, I just thought I would share that technique to getting the encoder, the differential, the coder counts that you want into the compute.
Hey, Doug, I have one question.
Okay.
I'm not sure how long it takes for, let's say, line 104, where it does a read trig and all that. Would it be of any benefit to move line 109 right under 103 so you do the read on left and right at the same time?
Well, this is me being lazy. All right, this calculate encoder, this one does both of them. It feeds this. So there, yes, you could change this function right here. You could change it so that, you know, it only did one motor, and then you could designate the left motor or the right motor. My personal, I know that the compute statement is very, very fast.
Okay.
And these guys here, you know, this isn't going to take any time. And I guess what I'm saying is this seems to work pretty well. Okay. You know, I can make this robot crawl in a straight line for a long distance. Now, so what's going to happen for the line follower is there will be essentially an additional factor that's going to be steering. Otherwise, right now I can have the K120 board actually sending down a steering value, and then that one will be pooped into the motor controller. Now, right now I haven't really seen the effect of the so how the steering will actually adjust the set point. It'll be plus or minus whatever the steering value is off the base speed. Now, it looks like the camera is going to run around 2020. I haven't since I used their IDE. This is their IDE right here. Since I used their IDE, here you can see this is just sitting on my desk. So here's the line. And what I'm doing right now is I'm just looking at pixels across here and determining this edge and this edge of the line, and then calculating the value in the middle. So getting close. I should be able to at least find out if this works as well as the Husky lens. By the way, the Husky lens just updated their Kickstarter. They have added an additional functionality to the Husky lens called object recognition. Not object detection, object recognition, which looks really interesting, and it can do such things as let me send you the link real quick. Give me a second. I think it came in here. Let's view. Okay, here it is. Okay. Oh, don't they have a link? Okay, here. Come on. All right. I'm gonna just copy this into chat. Okay. So let's see. Is there anything else I wanted to show?
Hey, Doug.
Yeah.
Tab there. You're almost as many tabs as I do.
Yeah. Well, this is actually probably pared down. Let's see here. Oh, here we go.
Doug, I had a question on your PIDs, because if I understand, the premise that you had there was that you were concerned about variable timing between the compute operation of the PID loop, right?
Well,
like were you worried? If I understood, was the reason that you did that because you were concerned that basically the sample rate would vary? Was that why you did that?
Well, the timing between the computes could vary
from on a motor from one compute cycle to the next.
Oh, you mean between? Why do I have the two motors broken out like that?
No. I mean, why did you go to the trouble of, I guess I was trying to figure out I was trying to make sure that I understood the assumption of why you were using the PID loop.
I want my PID input to be as accurate as it can be, because the output's going to be based on the input.
But accurate? What do you mean input accurate compared to
Otherwise, as the wheel turns, you're picking up encoder ticks. Okay, and if I'm saying I only want 6 encoder ticks per period. All right. I don't want 4. I don't want 8. I want 6. All right. So I want to make sure that I'm counting all the same amount of time every time it goes through. And I don't want it to be like, okay, I added another subroutine and now I've got to change anything. All right. Because let's take a worst case. Like I say, the worst case would probably be 19 millisecond loop. All right. And I've got my sample time set to 20. So it goes around once, and 19 seconds later, not 20, so it doesn't fire. It goes around now, and it's 38, and it says, oh, that's greater than 20, and it fires. Okay? So,
okay. That's
now, I want, what I'm getting is I know what my reference is. I know what I want. And if it's spread over 38 milliseconds, it's not going to be the same time. That's what clued me into the problem. Otherwise, I had everything tuned up, everything was rolling, but instead of 10 RPMs, I was getting 5 or 6. Okay? And when I did this, then I got 10, because what I'm doing now is I'm taking whatever time it takes for that compute to kick off. It's going to say I need the reference amount. I'm going to compare the input against the reference amount of ticks. And on the reference, it's just a calculation of how many ticks I need for a certain RPM. So that one is known. And you have to have a time factor in that, and that's what I call my loop time, okay? It's not the loop time that it actually loops. It's the loop time that I want the compute to be between.
Right.
Okay.
And it should be set for the same time as your sample time, or your PID sample time.
So I have an alternate approach that's not what you did, and it's
Okay.
not the libtask that Dave Anderson used.
Okay, well, let me, what was I going to show? I thought I was going to show one more
I'm going to
thing.
show something else.
Oh, no, I want to make sure I get that link put in the chat. That's what I want to do.
Well, actually, I tried to find it, and it turns out that unless you're a backer of the project, you can't go to that post anyway.
You can't?
No, I got to the thing, and it says this post is for backers only. If you're a backer of this project, you can log in to read it. So unless you've backed the Husky Lens project, you won't be able to read that.
Hmm.
Yeah. Whoops.
Oh, let me just show this page here.
Ah, that's a good idea.
Oh, let's see here. Now, I don't know if that firmware is available.
I've tried the object recognition, and it doesn't seem to work that well. It can recognize a few things, but...
Yeah, it only has 20 things in its library, so you have to be able to change the library if you want to look at, you don't want to look, I think it's cat, dog, flower, things
chair.
Like that. Yeah.
Mask.
Can you change the library?
Yeah, you can. I haven't really looked into how, Jack, but
covers basic farm animals, I guess.
Yeah.
I guess you don't know whether it's using TensorFlow models or what kind of model you're poking in there.
Well, okay, since it uses the K120, and I suspect, otherwise, the Max Pi boards, I suspect that the Husky Lens is simply a Max Pi board with custom firmware.
I think to answer Jack, it looks like this new feature, this object classification feature, is such that you basically go into a learning mode, feed it a number of images of the thing you're trying to teach it, and after it's seen those images, it then can theoretically recognize that as a new object. So this sounds like maybe this is the learning feature that we're looking for.
Isn't that the object tracking part, or is that for the recognition part too?
Looks like it's recognition.
Yeah. Anyway,
well, that's how you do it anyway. If you didn't have this thing, you'd have a whole, like in a lot of places, you'd get a whole bunch of images. Say, I have images of this. Hey, go run your models on it, and here's a test image. Did you find it? Yes or no? And okay, go tweak some things and get better. You know, you missed it, and have it do like this competitive neural networking sort of thing. So, or it's competing neural networking things till it figures out what it cares about, and that's. Maybe they figured out some kind of better way to do that local.
Well, I just don't think that in the existing software, on the one that I've got, there is actually a way to train it. I mean, maybe this is the new feature we've been looking for, because I couldn't see, Harold, how to train the thing. It has these hardwired ones like chair and monitor, but if I wanted to actually have it recognize my cat as my cat and not a different cat, because my cat is a particular color pattern, there's no way to train that. And I think maybe this is what this is for. This is a new feature.
That'd be really cool. That'd be really cool.
Okay. Okay, Carl, you were going to show how you do it?
Well, I was going to just describe it because my code's nowhere near as single-page viewable as yours, because it's in the midst of everything else.
Okay.
And I'm verbose. But in the scheme, okay, so with the idea, I was concerned from the start of having the loop be sampled on a regular interval, on a regular, precise periodic interval. And for as nicely as you can do, like things in Raspberry Pi and higher level, they just vary around. And what I did in this one, and I couldn't get the libtask to work on Arduino, much as I tried and wanted to. So I went the other route and I used the interrupt routine. So that's where, as you look at the scope trace I provided earlier, everything runs at 20 millisecond interval, and it's really precise when it fires the interrupts. And the ISR sets a flag so that the loop in the Arduino code is very short. All it does is check to see if the flag is set. If the flag is set, it runs all the tasks I queue up in the 20 millisecond period. So now then when I set the timing for the control loop in the PID library, I set that to be something close to 20 milliseconds so that the math would work out, but I think I made it to be just under 20 milliseconds. So what it means is that every time the interrupt fires at precisely 20 milliseconds, on the next loop iteration, it goes and the PID library says, is it time yet? Oh yeah, I'm overdue, and it runs. So the net result is that I have, as best as I can tell, I have that control loop running as close to the 20 millisecond interval as I can get. And it lets me stack up the sampling of the encoders and all the stuff that's timing sensitive. I put that at the start of the loop so that it samples, computes, outputs, then it does its other varying timing things. But it always does those 3 time varying critical things at the stop of the loop.
Yeah, but I think this is why, I think you fall for this problem, because I've approached that way too, Carl. Otherwise, I can make the loop precisely 20 milliseconds. That's pretty easy to do. I do a millis at the front, a millis at the end, and I wait until, I create a delay that just sits there until 20 milliseconds is up.
Okay.
The problem is, and like I say, 19 is actually the worst. But let's use one that's a little quicker to go around. Let's say your loop is 15. You're saying it's 20, but let's say you got your sample time set at 15.
That's fine. I can do that.
Okay. If you're set,
I can do that with the interrupt routine. I set the timing by the interrupt routine.
Yeah, but what I'm saying is, okay, so when the compute goes around the first time, at 15 minutes, you're at 20, so there's 5 seconds, 20 to 5 to 15 to 20. There's 5 milliseconds difference. So it says, yeah, man, I'm firing. Fires, okay? All right, now the next time around, it's going to fire 15 milliseconds from when it fired before. So it's going to fire at 10 milliseconds into your second loop. And then the next time it's going to fire 5 milliseconds into your loop. And then in the next one, it'll fire right at it. And you'll otherwise, if if your sample time is exceeded, it's going to fire. It's going to creep. One of them's going to creep out of sync.
Well, that's why I watch and make sure that all my tasks execute within 20 milliseconds, because I mean, whatever I set the interrupt timing to is hardware driven. It's within microseconds of accuracy. I mean, it is what it is. So then,
but that means every time you change something, you have to everything gets.
No, I don't have to change anything. Not at all. Because the hardware controls the timing, period. And then the tasks just take however long they take, and then the main loop just sits and waits until the ISR flag is set. And the ISR flag only gets set whenever the timing fires it. So it always happens right at the same time.
Yeah. Are you doing that much in your intervals that it can actually throw off your?
I'm at 8 milliseconds right now out of 20. I got a lot of headroom.
Yeah.
Yeah. Yeah. See, this one's going to run at 3 milliseconds roughly. Well, probably 2 once I take all the rail out. But the thing what I'm saying is, no, I still think you're going to find that it won't happen every time, Carl, but some number of times it's gonna flip over and get a second one.
I'm totally lost here, Carl. Just to correct, I'm doing the same thing you do. That is, I have an interrupt that for my samples. So the samples always have exactly the same time interval. It sounds like that the problem, and I don't use this Arduino library you're describing. It sounds like the problem that Doug is describing is that he has 2 loops and they're not synchronous. That they drift apart, and I don't really see exactly how that happens. If I'm sampling the encoders let's use your number. I'm going to sample the encoders every 20 milliseconds. So however many ticks have happened in that 20 milliseconds, that's the number I save. I actually call that the velocity. So I have a left and right velocity. And then I've got 20 milliseconds to do whatever processing I want to do, which is, the processing I do takes microseconds. So it'll be over and done long before the next sample comes around. So I don't see how those can drift apart. I'm a little confused by that.
Okay.
There is a way to.
From A210 is asynchronous with the PID loop, and you can miss or get out of sync. Say you're only 15 frames per second or 15 updates.
Okay, Carl, I see what you're doing. That makes you're actually sampling on otherwise your 20 milliseconds is a sample, so you're only taking you're only taking the encoder count differences you're measuring once every 20 milliseconds.
That's it.
And then regardless of where the compute runs, it's only going to use that as the input. That works.
Yeah, I'm not trying to measure the time between encoder ticks.
Yeah, that'll work. That'll work. That's a good technique. But this one's working real well.
Yeah.
I like that one. That's easy to do. I'll play around and see which one I like the best. Okay, but anyway, at least now people have two ways to go about it.
Yeah, no, it's neat. Options are good.
Yeah.
Hey Doug, I know you can get like say your frame rate off of whatever camera system you're using is less than say it's slower than whatever your PID loop rate is. You can get a situation where there are like two asynchronous streams and you're trying to. Yes. Yeah, well, so that can definitely happen. Where
we're gonna have to figure out. Unfortunately, when I use the IDE, they have a big warning on the bottom. The IDE will cut your
frame rate. Yeah.
Frame rate in half. Okay, so.
Right. Yeah.
So I haven't. What do they call? I just haven't used where just take it out of the serial, out of the USB and check what the frame rate will be. But I'm sure it's not going to be exactly the same.
Yeah.
It's not going to be 50, which is 20 milliseconds.
Right.
It's definitely not going to be that.
So, isn't that the generic problem that you're describing? Is the fact that that you have sensors whose update rate is less than the update rate you want for your wheels. And that happens all the time. Sonars, for example, are not going to return readings every 20 milliseconds because it depends on how far away the object is. But it's quite common that your sensors are collecting data at a lower rate than your control rate, and there's a number of different ways to deal with that. I've found that the easiest way to deal with it is just to ignore it. What difference does it make if you come back and you have the same sonar reading because you haven't gotten a new one?
Yeah.
I haven't found that it makes any difference at all.
Right.
So you basically just get the last value you collected.
Yeah.
Yeah.
And I think,
that's exactly what you see here. Right, because this is on my donkey car code, right? That's what I'm showing is that the donkey car interaction on the top happens. However, I mean it's totally asynchronous with respect to the Arduino loop on the bottom. So the Arduino loop has 2 or 3 executions for every execution of the donkey car loop, but I don't care because I've got synchronizers built in, so that the Arduino receives a fresh set of data. And it just acts on the most recent data that it gets, and conversely, it shares its data to the Pi, and the donkey car on the Pi just uses whatever fresh set of data that it can use.
Right.
Well, I kind of agree with that. If we're talking the difference between 50 and 20, you probably can get away with it. With just letting it run. Well, at least I'm going to give it a shot. We'll see.
Yeah. Yeah.
The answer could be you go slow.
That's that max headroom effect.
Yeah.
Well, but at the end of the day, right? You're going to be limited by the sample rates and the difference in sample rates. Yeah. So that's going to set the maximum responsiveness that you could get at no matter how you do it.
Yeah.
Mm-hmm. Yeah. Well, so far, like I say, I found the Max Go not Max Go, Max Bit, which I'm using, to be really a good $20. I mean,
Oh yeah, yeah.
I mean, it
Can't
is.
beat it. Yeah.
It just can't beat it, and their software is improving quite a bit. If you're using their latest firmware, their MicroPython, for example, if you look at their documentation, it says things like, okay, they only have SD, they can only do FAT, well, and that you can't do FAT32. Well, their new software does FAT32 with no problem. So, I mean, there's a lot of things that, and it's just easy to work with.
Yeah.
Doug, which processor is this?
It's a K120.
It's
Ray, what's the
K210.
210? K210?
Yeah.
K210 processor.
Yeah.
Ah. Oh yeah. Okay. Cool. Thank you.
Yeah. But there's the Max boards, the MAIX. There's 3 flavors. There's the most expensive, which is the Go. There's the Bit, which I think Ray has, and then there's the Byte, which is what I've got. I've got the Byte and the Go. The Go, I use it for testing, but just because I can just put it on my desk. But the one in the robot is the Byte. There might be more input output on the Byte, but is it Byte? Is that what you got, Ray? It's called Byte?
Well, I thought mine was. It says Dan Doc.
Dan. Okay, Dan. I'm sorry.
Yeah.
It's not Byte. It's Dan. The Dan bar might have more input output, but unless you're going to program the K210 chip yourself and not use MicroPython, or even if you're going to use MicroPython, I'm only going to hook it up as a serial port, and then nothing else will be there.
Yeah.
And I'll have it basically as a self-contained sensor, and it just sends its output.
Yep.
So guys, I think 4 of us are kind of commandeered. I've lost track of the clock here. We have 4 people left yet.
Yeah.
See what they've been doing. So
sorry.
No, I'm to blame too. So we all need to apologize, I think. But let's move on. So we've got Harold, Jack, John, and David. So how about Mr. Harold? How's it been going for you this week?
It's going pretty good. It's make sure everybody can hear me. I just closed something up.
No, you sound good.
Okay. I have been trying to do a few things, and let's see. Let me pull it up here. If you guys present a little bit, I'm trying to get more of a presence on things. So to do that, I have decided to do the following. I have a Twitch channel, and the idea is I need to record all this video anyway, and maybe on the Twitch channel I might get a few followers. I've got 2 followers already. I'm booming, killing it.
You're rocking it.
With OBS, the idea is I'm going to record all the junk. Like this last Sunday, for my YouTube channel, I recorded a new intro video, which I'm okay with. And it only took me like 3.5 hours to record a minute worth of video. So I figure I'm killing it on that deal too. Actually, I was doing other things as well. I want to stream a bit, and I'm kind of an achievement whore, and you get achievements for streaming so long and so many hours within 30 days and those sorts of things. And so I'm kind of working on that a little bit. I'm also trying to figure out, like, you guys are looking at me through the teleprompter, and after I looked at the video, I didn't think you could see, and probably some of you can, some of you can't. And after I've looked at a lot in the video doing the editing, I'm like, dude, I really need to clean that glass bad. And so I'm trying to figure those sorts of things out in the middle of trying to line out my my YouTube channel and my webpage. By the way, last time you folks, oh, if you guys want to put in a comment, that's something I can do too. I threw this out, and Carl was very helpful, and as long as other people are very helpful, is I need a tagline. And so I went through there. Some of it I've got from you folks, and some of it I just did found a tagline generator online, started jacking in words, and the things that I kind of liked, I put up there. So I got lots and lots of feedback, lots of good feedback. So like there's a whole bunch of taglines there, and there's to be more. I've got a discuss thing going on there, and people got me some other stuff going on here. And now I've got a way. The problem with this is I thought I had a lot to think about with that. Now with actual feedback from real people who actually care about these things, that's given me a whole bunch more feedback. So I haven't chosen a tagline yet, but it's kind of getting there. And to that end, I'm updating my web page. I haven't updated in like 4 or 5 years. Started throwing some things up there. Found this thing laying around. I forgot I even made that blog post from like 5 years ago. So I figured, well, hell, why waste a blog post? And some of the ideas are that I was, and in fact, when you guys have been talking, I've been doing these. So I've got some projects I've started putting in there. One of those is like I need to make my own OBS screen changer. You know, I don't know when this is going to come in, but simulate a USB keyboard device plugged into a thing and a bunch of Adafruit little buttons. You know, those arcade buttons in a 3D printed thing. That sounds like a whole project that I could do and then try to teach somebody. I mean, because the part of the thing with my, I wonder what that is. I got to figure out what that is. But part of the thing is that in my YouTube channel is I've kind of settled on I'm helping people become makers. You know, going to show them the. Some people think it's hard. Some people don't go to start it. And some of that's come out of this group, by the way. We were talking about last time about bites of an elephant. You know, how do you start building a robot? How about you take a first bite of the elephant, and then, but how do you figure out what that bite of an elephant is? And if you got to learn something, fine. And if you don't got to learn something, well, that's even better. But if you got to learn something, fine. And the idea is I'll show you the screw ups with the successes, and hope you learn something, whichever you're watching my screw ups or your successes. And so that's kind of how that's rolling on that deal. So that's what I've been doing the last week, and making videos that do things. And where is it? Hold on.
Harold, what format do you make your videos in when you upload them?
In this case, that's something I ran into, which I was hating myself on. I am currently channel customizer. I am currently doing OBS, and this is writing something out called MKV. And I'm using Camtasia as my video editor, and it's a little blurry on there, so that's what that is. MKV.
Hello.
Oh yeah, there you go. And my audio is kind of off and sync, and I had to sync that up. And that's some kind of special format that, not special, it's a standard format that OBS likes to store things as by default. And Camtasia doesn't know how to import those. So I had to go get Handbrake to import the MKV, transcode that into MP4. I have no idea really what that did to the video, because there's like a billion options you can do on that. So I'm going to have to change my OBS stuff to put out as MP4, and they warn you about if you do this and you don't close the file correctly, then you could lose stuff. And, you know what I'm doing right now, you know, I can't believe anybody is going to, it's not immortalizable is what I'm saying. So I am not so concerned.
Well, the reason I ask is because I've run into the same problem. The little camera I'm shooting with, which is this GoPro, outputs this real gorgeous picture, 4K high-res MP4, which looks wonderful when I play it on my computer, but none of my editing software can handle it, so I have to convert it to something else. And when I do, it never looks as good.
It never looks as good. Yeah.
No, I was hoping you were going to tell me the magic solution to that problem, but you're saying you have
a magic solution yet. No, I found that one. I feel honored that you think I would have that solution. I truly do, but I have not found that yet.
David, one thing might be of interest. You know, some of these knockoff GoPros. Let's see if I can get this. You know, they're just knockoff GoPros.
Okay.
They're from China and whatnot, and you're probably talking $20, and they can do 1080p. Nothing, you know, not.
Well,
they'll claim that they'll claim they can.
My real life expensive GoPro can also do 1080p, but it seems like, I mean, what's the point, you know? Well, I got this really wonderful high resolution camera. It makes these gorgeous pictures. I'm just stunned at how gorgeous the pictures are. And then I have to turn it into a shitty format to share it with anybody.
It just uses an ultra optimized, super compressed format that you can view it, but you can't change it.
Well, and I've turned it into AVI. I've converted it into standard MPEG. I've converted it into digital video, which I think is what that MKV format is. And all the converters do the same thing, which is they take this gorgeous picture and make it look like junk.
What are you using to do the conversion?
At this point, I've been using VLC. But FFmpeg also has some converters built in. But it doesn't seem to matter what converters I've used.
Okay. Well, Handbrake is free, and I've used it exactly like twice in my entire life. And I didn't have time to go through all the buttons and whiz bang things and stuff you said, but it's recommended by the Camtasia people to use that as a converter, and it's free as well. Handbrake.
Well, I've got Handbrake. I've used Handbrake a lot, mostly when I wanted to rip a video off of
like a
YouTube.
Yeah.
So guys, what I would suggest is that I think a lot of these tools, they choose their own intermediate format to get from format A to format B, and you don't know what that magic intermediate format is.
Yeah, you don't know.
So when I was the Hebron video band dad for 6 years, I got fairly deep into this. So I would suggest that if you really want to explore the limits of your tools, what you might do is force it to an intermediate format by taking your MKV or whatever, it's super compressed, ultra optimized, looks great. Convert it to a lossless, because it's in a lossy format right now, right? So convert it to a lossless format, like an uncompressed AVI. It's going to be ginormous, and then go from that uncompressed, ginormous format down to whatever you want to get to, and I'll bet you that'll get you better, clean results.
Well, I've actually tried that, and
really.
Yeah, actually go into AVI specifically. So as you say, it takes this video that was 280 megabytes and makes it into a 4 gigabyte video, but it doesn't look as good as the original.
Oh no. Yeah.
So then I think it gets to the codecs and also the containers. Like
I think so. I think that's right.
Because like I know I tried 2 or 3 different, at one point I tried 2 or 3 different digitizers. So I had the same digital source and I digitized it with 2 or 3 different hardware digitizers, and the output viewed on the same screen came out with different color space, different levels.
Yes.
And it had to do with the encoders. I mean, literally the implementation of the decoders and the encoders. Somebody's math was off, knobs were twiddled somewhere.
So you're saying it's my crappy encoders rather than my crappy video processing?
Well, I think right. Yeah, no, I think it's the encoders and it's the settings because, and then there's another thing too. If I remember right, like AVI, even MP4, it's just a container. Inside the container can be supported many different kinds of formats with settings. So not all AVIs are made the same. Not all MP4s are made the same. So it really gets down into.
You think I can push some buttons or select some options that,
yes,
even though it's AVI, that would look better.
You got to drill into what flavor of API that it is. And I used to
got to know what's going on.
Oh, damn it, not that again. But
I don't want to have to learn anything.
The trouble is, I knew it at one time, but all my tools were on this Windows XP box with the this old. Anyhow, I'm sure they don't run anymore, and all the formats are new, so you got to find a whole new tool chain now to figure out. That's
part of my problem. My Windows XP machine with all the video processing gear is at work, where I have no access to it, and so I'm trying to do these things from home, where I don't have that machine. I've got my Linux machine, and so that's my bottleneck. I have to ask you an off-topic question, Carl. Were you the 7 years that you were at Hebron as a band videographer? Were you there? When was that? Were you there during the time my son was a band director there?
It was call it 2006 or 7 to 2012. It was
Jonathan Anderson was the percussion instructor there at that time.
Oh no! Then Baldwin took over. Scott Baldwin.
John's a tall, skinny kid.
Was he before?
With the hair. Yes, exactly. I think he was there for 3 years.
Okay.
Before he went over to a Capel.
Oh no! It was Scott Baldwin for the whole time in the percussion when I was there.
Yeah,
and my daughter was in percussion, so I knew him pretty well. They did the percussion concert each year. So I would have in the Hebron High School auditorium. At one point, I had 8 cameras, dads with cameras scattered around the auditorium, and like 5 pairs of stereo mics. And then I would bring and I would mix it all together into a 2-hour-long DVD on my Pentium 4.
I love dads with cameras. We need to trademark that. Dads with cameras.
Yeah.
Well, so you know how hard it is to record the audio for percussion because the dynamic range is so incredibly wide that if your loud parts are not distorted, the rest of it is way too soft, and it requires some sort of hand manipulation typically to get the gain levels. We'll have that non-robot talk.
We'll have that talk because the whole video production thing is a fun hobby. So moving on, I think we scared Jack away. So, well, Mr. Anderson, you have the floor. Let's go back to robot for everyone else here.
Well, let's see. I'm going to try to do what I did last week. Let me unplug some things and see if my computer crashes. Am I still there? All right. Yeah. I'm going to take my camera over here, and once again, I can't see what I'm looking at, so you'll have to tell me if you see it or not. Plus, I just dropped my phone on the floor. Can you hear me?
Yeah.
Yes.
All right. Okay. Well, I'm going to try to point this down. Can you see anything there?
Yeah. The thing. With the display.
A display and a little gray box with buttons on it?
Yeah.
It looks like the kind that if you push the button, something explodes somewhere.
Where's Tom Cruise?
Okay. So in our last action-filled episode, good Lord, I keep dropping my cell phone. All right. I'm gonna tape it down to the table here.
We should do that. Doom, 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 doom.
Didn't know this thing had a soundtrack, did you? I think Mr. Anderson has muted himself.
Yeah,
and he's frozen.
He's frozen.
Yeah, he froze.
His video feed is
Oh, look at all this.
frozen.
We got Noah.
And Murray's on mute too. Everyone's on mute tonight.
Except me, I should probably go on mute.
I was just going to suggest maybe we should move on from David and he can come back online because he.
Yeah, I'm right there with you. Mr. John Kay, you are next.
Okay. Well, unfortunately, you said Jack is not on, right? I was going to show him. Oops, well, I wasn't going to show him. Ah, yes, there he is. The other week, I saw that on the news. So Jack, I was going to ask Jack how his little golf cart thing was doing. Same at one restaurant when we had when you couldn't go into the restaurant, the guy basically took a real cart and did a remote control to deliver stuff to the cars. So I thought that was interesting. So for Jack, that would have been a good idea. And then I think yesterday I saw on the news over in Japan that basically at the coffee shops in the future, they're going to have the machine make the coffee and then it'll put it on a cart that takes it to the table, sort of type thing. So as how to use the applications out there.
And there'll be a robot that will drink it, so we won't even need humans in anywhere.
Hey, well, eventually we'll get there. You're right. So,
can you guys hear? Can you guys hear me?
Yeah, he's back.
You're back online.
So
evidently, when I moved my laptop over there, I lost my connection. So I'm sorry,
David,
John, go ahead.
David, we're moving on to John for a bit.
And then we'll go back to you. So the other thing I did during the weekend, I actually started to put another layer of the thing. So I actually now have this thing in the middle here. So the next step is to put the arms on. So here's, once I get the screws or glue gun out, if I can get this in the right spot, it's going to go like that.
Could you hold it up a little higher, John?
Try to. There. Does that work there? Yeah. Okay, yeah, there we go. So basically, this is the arm.
There it is. Yeah.
Okay, yep. It's going to go there,
right.
and then what I'm going to do is, what I'm going to do is add another little arm out here that will sort of go in like that, so it could go up and down and like that. So I need to design the next part and print. Because the printer here is a little slower. It takes about double the time, but hey, it works. So that's basically what I did over the weekend when it was pouring down rain.
Coming along.
Cool.
Looking good, huh?
So, yeah. So probably maybe by next Tuesday I'll have more put together. The key thing is hunt down small screws, which I probably have somewhere around here. And then I'll print out the other part.
That's cool. So hardware first and then the software to make it move around?
Well, I had the software for the feet. I didn't have the software for the arms, but that's basically just copy and modify and change the address or two. So.
You would make the feet motions apply to the arms? The poor robot.
Hey, it will be a rear dance, I guess.
Kick itself in the head or something.
Talking with his feet again. Okay.
I still think you should make it, look like it scratches its butt.
Well, actually it could. The way it's designed.
It's got at least one arm, yeah.
Got good reach, huh?
Yeah.
Well, yeah, it will. Because reality is... okay.
You can get with Ron Grant for some reason.
I'll take the middle part. See, there's the middle part that basically goes in. So, it could go in the front or the back. So, it literally could. I did it mainly for balance, but it could.
Well, everyone needs to keep their balance about them, that's for sure.
That's right.
Yes.
Especially when you're scratching.
Cool. Well, somehow we've made it around the table, and we only lost Jack, but it was good you could get here tonight. Maybe school let out, and he'll be able to join us more in coming times.
Carl, I have a couple of comments.
Yep.
Yeah, I don't know when my computer crashed. Did you guys get a view of my little work set up there on my bench?
Oh,
yes.
What we saw was basically your box with a bunch of buttons and some wires running this way and that way. And beyond that, we have no clue what it will do.
Oh, okay. You should have seen the
We saw the Nucleo board.
You did see the Nucleo board sitting on the little breakout board, and with a serial LCD display connected to it. Okay, so basically what I did this week was I worked out the technical problems with moving to this F446 STM board that Dave Ackley recommended. Thank you, Dave.
You're welcome.
It solved all my problems. Plus, I have a whole bunch of leftover pins now because it was easier to implement it on that one. So I've actually started the process of porting the software. This is just as a reminder. This is my attempt to port the JBot, the outdoor robot code from the Mini RoboMind, the 332 controller, to this ARM controller. And it looks like, just as I've done sort of some analysis, that about something like 75% of the software will just move over directly, but I won't actually have to do anything to it. I just had to change a bunch of the drivers for the new hardware environment. Having said that, as I dig through the code, some of the things in those drivers are propagated outward to other things that make the problem more complicated than it should be. So, as has always happened, if you guys have the experience, when you port code from one environment to another, you always improve the code. You always make it better because you get to go over it again. I had one of my composition professors when I was in college said, when you copy a score, you copy a piece of music, you always improve it. Just because you're having to sit there, write each note down by hand, and so you're really forced to think about it. And so the port is going to be more than just a port, which is what I originally had started with. It's going to actually include quite a bit of redesign. And that might make it easier to port in the future, or maybe not. I don't know. But I was actually kind of surprised at how intertwined things were, and how difficult it has been to separate out the hardware from the stuff running above it. So that's all. This is all an intellectual problem. It's not really fun. There's nothing that moves. I did get, I got a trace on an oscilloscope here, and I can turn knobs and push buttons and make that trace move around. That's the closest I get to any actual satisfactory feedback.
That's worth it, right? That's why we do this.
It's one of the wonderful things about programming robots versus programming almost anything else is that when you're done, something actually moves. I'm sure you guys had the experience of spending hundreds of hours on a piece of software and debugging it, and when you finally got it to work, it came back and printed OK on the screen. That was it. That was what all that work was for.
Yeah, rather than a stack trace.
Right. Yeah, exactly.
Every web page ever created, by the way.
Better than scratching an itch.
You get an OK back. 200 OK, done.
Yeah.
So that's where I am, and it means I probably won't have anything fun to show for a long time. I can show, look how all this software that doesn't do anything because there's no robot attached to it now runs in this new environment.
But it passes unit test. and then that means that when the time comes, you turn it on and the sky just fills with rainbows, right?
Well, that robot, I think that robot was built initially, I think, in 2008, and it's had lots of things added to it in the intervening 12 years. Lots of experiments, and there's just tons of software in there to do. One thing I did, I wrote some code at one time. Once I put the camera on it, so that I could have the robot right next to me. It's got a waypoint that it just records because it's standing next to me. And then I kick an orange soccer ball, and it chases the orange soccer ball and pushes it back to me, and then reorients itself to me beside me. And I got that working about 75%. And then I got bored with it, but all that code is still there.
So it plays fetch.
Yeah, exactly. Play fetch. exactly right.
Then you need to put John Kay's robot on so it can pant with its tongue hanging out for you. See?
Yeah, there you go.
Well, Doug, do you remember one of our ex-members, his name escapes me right now, came down from Chicago when we held a robothon at the Perot Museum. And he had a robot that was a little robot dog, and it could chase an orange ball. And then once it got the ball, it would look around and recognize a face, any face, and it would take the ball to a face. And that was like, 10 years ago. I can't remember. Do you remember this? I think it was
Sony IBO that did that. AIBIO, a robot by Sony that would chase a ball and feed it back to you.
Yeah, this wasn't an IBO. It was something that he built himself, but it was that same sort of thing.
The only person I can remember with the dog robots was Gus, and those were mainly the Sony robots. So I don't know.
Those were so disappointing because they could really hardly even walk.
Yeah. Well, what he would do is when we would have a public gathering, I think he had 3 or 4 different versions of it, and he would get the little kids to play with the robot dogs. So they'd sit on the floor, he'd get on the floor, he'd put out a tarp, and he'd put out the dogs, and they'd get them to go, and the kids would just they were like magnets. The kids would just slide over and sit down next to him. I mean, I'm talking about the 4 to 6 year olds. They just loved it.
Well, I always had a little trouble with that. You may remember at the time there was this huge thing that, old people will have these instead of a real dog because it's so much easier to take care of and everything. And it didn't behave at all like a real dog.
Yeah.
And the only reason people thought it should behave like a dog is because that's what the plastic outer case of the robot looked like. And my observation of its movement was that it would have been more appropriate if the outer plastic case had looked like a turtle, because that's actually, then people would have said, oh, look, it's just like a turtle, instead of saying, oh, look, it's just like a dog. It just depends on what kind of plastic you have around it. But the behavior was more turtle-like than dog-like.
Yeah, but if you want to sell them, you don't want to sell turtles, you want to sell dogs.
Yeah.
So.
I'm trying to think philosophically what I can pull from this. Maybe I should dress differently.
A turtle.
Suit the tie, Murray.
Yeah, exactly. Get a haircut, you little punk.
But you realize that those robots, the dogs, they're actually now making them the little rabbits and type stuff for in nursing homes and that, where they'll over in Japan, back to Japan, but they're on the edge of stuff like that. But they're making them for to take the temperature of the patients during the day and stuff like that. So it really is
a giant tall rabbit with an evil face.
Yeah, not that bad. No. It's small.
Murray is actually a clown face.
Yeah, exactly.
It's not really much of a face. It's more
part
white.
of the dilemma here.
That's why I'm glad. I caught a couple of robots in Walmart running around taking inventory and doing that kind of stuff. And there is no doubt that this is a robot. But if you could dress it up as an evil rabbit or an evil clown and do the same thing, that would be some fun there.
Yeah, the Walmart robot when the thing
evil rabbit clown. Yeah. What was that movie called?
What was it?
Donnie Darko.
Johnny Darko. Yes, thank you.
Then there's what is it? Killer Clowns from Outer Space or something? That was a thing back in the 80s or something.
No, Johnny Darko is a strange movie.
Yeah.
Disturbing.
Yes, very disturbing.
Part of the dilemma here is, at least for experimental robot builders, which is the way I think about us, in some sense, we have a lot more freedom than somebody who has to generate some commercial product.
Yep.
We can try technologies that may or may not work. We have the freedom to do that. Whereas if you're generating a commercial product, there's a whole different set of criteria about what you're trying to make and who you're trying to appeal with. At the same time, I would have to say that a dilemma of experimental robotics is that we're a solution in search of a problem. And if you sit down with any business guy with a bunch of money in his pocket, he's not going to like to hear that.
No.
You know, it's exactly the opposite. It's backwards in the way business ought to be done.
Well, unless you're in Silicon Valley, then it works the other way around. But
and there really is. There's no such thing as a robot. You know, there really isn't. It's something that came out of science fiction. When most people think of a robot, what they think of basically is the Tin Woodsman. That is a human being made out of metal, but who has humor and desires and so forth. They don't think of their dishwasher, which is a robot most people have in their house.
Yes.
Well, it's the C-3PO versus R2-D2. Which one is the robot?
Well, I think it's the C-3PO versus a Roomba. You know.
Well, I'd even go further than that, because I was before all the COVID stuff hit. One of the reasons I was building my little bit of robot thing and doing was also because I want to do a talk on it. And one of them is, you know, industrial strength robotics, blah 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 blah. And so I was going through some of the PowerPoints and how I was going to do, and said, you know, okay, let's define what a robot is. Just like David was thinking about this, and I'd show up a couple of pictures, and I'm going, and I would. One of them would be like one of the battle bots. Is this a robot? I would certainly say no. And then my very next slide was going to be a Nest thermostat that you put on the wall. Is that a robot? And I was going to say, absolutely, this is a robot, because it's changing the outside world of something using software with input from it. You've got sensors, and you're changing an external thing, even though it doesn't have wheels to run around. It's certainly doing robotic type things for you, right? And I just want to challenge. The idea was to challenge the notion of what people have thought of as a robot, because it's usually the C-3PO or the big, 10-ton crushing robot things that they got in BattleBots and everything else. And there's certainly way more than that in this space. You know, certainly way more than that. That was the concept between there and that little bit of intro.
Well, another way of looking at that same thing, at least as I've thought about it, is that we actually suddenly have all this technology. We've got microprocessors, and we've got little tiny servos and linear actuators, and we've got all this technology. And I've used this analogy before. I think in robotics, in a lot of ways, we're sort of where flight was back in the Wright brothers era. That is, nobody really knows how to do it right. They don't even know if you did do it right, what would that be?
Yeah.
And so a couple of guys who are bicycle makers in their garage can actually make a significant contribution. People in a big academic or industrial setting don't necessarily know any more than we do about how this ought to be done and what the final solution, or even an intermediate solution, should look like. What is a robot? So, as I say, I think we have a lot of freedom in that sense. We say, well, maybe the robot's the wrong word. Maybe it should just be automation or artificial intelligence applied to, hardware.
Those industrial guys certainly have bigger budgets than we do. I can tell you that's a big difference there, right? I mean, like those guys at Boston Dynamics are like off the chart cool, right? With their robot dog and
thing. But what else are they besides off the chart cool? That's my exact point. I'm not arguing with you at all. I'd love to have one of those little two-wheel, what were those called? The ones that can run around and balance and have legs and everything and jump up in the air. I would love to have one of those, but it's not clear at all to me what you actually do with it, other than just say, this is really cool. Furthermore, I think that if there actually was some useful purpose for it, that I would lose interest.
Actually, it turns out that I think that the Boston Dynamics dogs have already seen some application, and I think it's going to be in crowd control. They've been using them as surveillance, and they could just put a weapon on one, or tear gas, or whatever, or on a gun. And if you can imagine 30 or 40 of those coming over a hill in a street or something like that, people aren't going to hang around if there's tear gas mounted on the top of those things.
And so not to press that point just a little bit further, you guys ever watch the Netflix series Black Mirror?
little bit.
A little bit. Never watch it. Okay, you probably need to go watch it at some point. It's like Twilight Zone for now. Okay, it's got that twisty thing on it. One of the episodes, and some of them are kind of slow, but it's British, so okay, I'll give them that. But not to be British so much, but it's a little slow for me. Of course, I'm an impatient American person, so take it what you will. There's a couple of real telling episodes in there. If you watch the first one, just get past it because it's like a shocker. And if you're going from season 1, episode 1, first one is just get past it. Trust me. The rest
a couple of them are kind of dark, I thought, but yeah.
Both of them are dark. And one of the episodes of one of the last seasons, basically they have a thing called a dog. And I forget how it's spelled, but it's an acronym. And this thing is essentially a Boston Dynamics dog with various kinds of weapons, AI smart enough to go. They're using them in a military kind of way, rousting people up. They went awry and started killing everybody, not just the people that they're supposed to kill, killing everybody. And they got enough AI and smarts in them that as they were driving down the road, one of the people was trying to drive away from them because the robot can only go so far so fast. Of course, it's loaded with weapons and stuff. The robot jumped it, recognized the van, recognized the model on it, was able to get into it, plug into the data port on it, start it up, and because now most of the drive yourself vehicles and everything have actual motor actuators on and assistance on the steering wheel, and since it's gas by wire anyway, right? They can control everything in it and started chasing them down the road with this thing. And this is how far this thing went. And so you're not too far off from this being a crowd control kind of thing. You know?
Well, I'm not saying actually what I was talking about actually is already happening. In the news is if you search for Boston Dynamics Singapore crowd control, they're actually doing that.
Oh yeah,
I got to go search for that now.
Yeah,
you're scaring me, Murray. You're scaring me.
Yeah, it's a step beyond sheep herding, right? Because they had one of those Boston Dynamics things herding the sheep around too.
Yep.
Well, they had, at least the other day I saw where they had basically a cone type thing, sort of like the derricks, where they would basically go in a park and, tell people as they was rolling through the park. Right. Yeah,
exactly.
But you're right. The dog is actually, they've gotten the dog down to the size where it probably would be a better candidate along that lines. Yeah,
but it's more trustable. To get to David's point, though, I spent 4 years on a PhD program that I never finished in England. And having done that, one of the things that I learned was that how do you put it? The sociability, or can't think of the way to put this, the actual academic world isn't actually that suitable for a lot of things. That you have to write papers, your papers get signed off by your advisor. All the way that at least in England, and as far as I know, the US too, that the way that master's and PhD students are forced to work through the system, it doesn't always really encourage the kind of thing that we're talking about in this group, which is you have the freedom to do anything. There's almost no freedom. You have to find an area of research that nobody else is already in, because that's the nature of a PhD. You can't duplicate. You can't, and you have to come up with original research. You've got to find an advisor who will buy that's what you're going to do for 4 years. You've got to get all these people on board, and you got to get through the system to get a master's or PhD degree. It's not really to do original research, really. It's to get the degree. And so there's this sort of funneling effect that keeps you from actually having any freedom to do what you really want, which is to find out, what this thing can do. Or, you're in this open path going on this journey and you don't even know where it's going to lead. Well, with a PhD, you have to know what the end of the journey looks like before you start.
And we actually have the freedom to go down roads that end up being dead ends. You might work for a couple of years on something and then say, well, this is just not going to happen. You can't get somebody to pay you or give you a grant to do that same thing.
That's true.
You say, well, we've studied this thoroughly and it just can't be done. Sorry, thanks for the money.
Or in John's case,
was when I was in high school. Oh, go ahead, Ray. The closest thing I can think of was when I was in high school. One of the guys, I was in a radio controlled sailboat group, and one of the guys in the group, actually, this is in Des Moines, he worked for the IBM lab in the area. And from what I understood, is this is in the 70s. The thing was is that he would be able to, they had any kind of budget they want as long as they could justify it. And so it's sort of what you're saying, David, that there was a point in time when companies like IBM and Sun and Apple, when they were flush with money, they could effectively say to a small portion of their staff, go off and do anything you like as long as you can sort of justify it for a year or so. And so that's what, as far as I can understand, IBM did in the 70s and 80s, was that they gave guys almost unlimited amounts of money if they could justify it to go off and try new ideas. And, we're on a lot smaller budget here, but we have that same kind of freedom, which is nice. And the sensors are cheaper.
Yeah.
Everything's cheaper.
Except for the time. The time. Bring me my TARDIS.
Yeah. Time disappears.
That's what's been so wonderful about this whole quarantine thing.
You're digging it.
I am.
Careful, it might grow on you.
I told people before, only half joking, I say, well, what do you do at SMU? And I say, well, I'm a systems analyst. And they say, well, what is that? What does a systems analyst do? And I think, well, that's the glory of being a systems analyst, is that nobody really knows what it is you do. Even the people I work for don't really know. So as a consequence, they can't really tell whether or not you're doing it.
Yeah.
That's good. No
Yeah.
You can also do it from home.
That's a great
You
role.
could probably do it from the deck of a sailboat.
There's an experiment. I think you should verify that. Next time you have to go into the office. No.
I will say that I need some funding in order to try to determine whether or not systems analysts could be done from the deck of the sailboat.
Yes.
And I might end up saying, turns out, no, I tried it for a year and no, it doesn't work.
As long as the boat didn't rock and your satellite was in one spot, you probably could do it. Connection, that'd be the problem.
I've actually been kind of humbled to find out how much I can do from home. I would say at least 90% of my job I can do from home, which I never really knew before this.
And if you're comfortable doing it that way, because what gets me is that those of us that have been doing it for a while and kind of like it can work out well. But for some people, it's not a good environment. People can't deal with it working from home.
I can see how they would. For one thing, you don't ever get to leave work.
I've been in that mode for 20 years.
Especially if they call you in the middle of the night. Yes, that can be a bad thing.
Yeah,
so.
Yeah, you don't really get to leave.
That is a downside.
John knows what I'm talking about.
Well, I see it both ways. I'm one of those people that do like that to be in the office, but in other words, you get, in this case, we're actually seeing each other, but in work we tend to not do that. So the problem is you don't know if they really are busy concentrating on something, so you'll get these tons of pings while you're trying to think of something hard on it. So, which is where if they were in the office, you could walk by and sort of see if they're tied up or not and engage. So that's one of the problems, that some people don't interact well with it. So they'll just ping you, without really asking you, oh, are you tied up? Do you have time? So that's one of the things I've learned. And some people, they don't like being interrupted effectively. So then it gets into a problem that you're missing some of that. And then you don't get the handshake. In other words, you don't get that visual acknowledgement in the office aspect.
Well, let's see. I think
and then the other thing is everything can be done today or the day before, and they don't really know how to spread out time well. So
I think two of us are retired. Isn't that true, Dave? You and Doug are both retired. Isn't that true?
Yes.
So you guys should have all the time in the world and be able to be incredibly productive and creative based on what we're saying. Is that
Oh
true?
yeah, right.
But the catch is,
Unless you're a full-time caregiver.
the catch is, I was going to say, because I know at least 2 people that retire, and they're more busy now than they were when they were working, it seemed like. So they always told me, oh, I needed to go off and run, do this errand or do the yard work or something. So, yeah, I don't know if having more retirement time is a good thing or not, because I think they tend to they drag out the work they're doing more so instead of being focused. So, yeah, as I said, I've seen it from all different angles.
So I'll tell you, Murray is now giving me nightmares. I posted a couple links in the chat, so I hope they give you nightmares too about those dogs patrolling. Apparently, they are not tracking people and not recording faces. Yeah, right.
Apparently, that's like Google doesn't spy on us either, right?
No, not at all.
No.
We're not trying to sell you a car. We just want to be your friend.
Here's that new pair of underwear with a video camera built in.
Yeah. Whoa, hey.
Or the Microsoft. Why is Microsoft funding the virus inoculation, the vaccination, so that they can embed trackers in you as you drink the vaccine?
That's right.
I don't know. I'm not saying I got tinfoil hats, but I've got some of that going on. But some of these conspiracy theories that people come up, they're just, come on, man.
Amusing. Sad.
Surely you remember, Harold, there was a poster back in the 60s that was very popular, and it said, just because you're paranoid doesn't mean people aren't out to get you.
Well, that's very true.
Well, I have a question for Doug. Doug, I had a friend who worked for Microsoft, and he made a whole bunch of money, and then he retired. And he was like 35 or something like that when he retired. And he told me at one time that he thought it was a terrible decision that he made to retire that young. And so I was curious, and I asked him why. And he said, well, he actually had a number of reasons. But one of the ones, he said, before I was retired, I knew that on, for example, Saturday morning at 9 o'clock, I was going to take my daughters to ballet class. And then I had to go back and get them at noon. So I had 3 hours where I could work on a particular robot problem that I was interested in. And so I would. But he said, now that I'm retired, there's no urgency. I could do that today or I could do it tomorrow. And he said, as a consequence, it doesn't get done at all because he doesn't have that pressure. Did you find that that was true when you retired?
Well, first of all, like I said last time, retiring early for me at 58 was the best thing I ever did. I mean, I retired.
A good decision.
Good decision. Now I don't know about 35, but at 58, I had basically 7 years before 65 where my health was better. Otherwise, when you get up to about 62, every year they take something away.
Oh, come on. Give us a little hope. Give us a little hope.
I resemble that.
Well, I know. I'm just saying is that the difference between being 58 and 65 or 69 is there's a big difference. It's small, it's gradual, it's every year. Okay. I mean, I had a metric of the trail. It took me 8 years to get through it. And I can tell you that, the last year I was dragging butt compared to when I first started out. But that's a different story. But now your question about focus, yeah, it depends. You get bursts. But when I was working, I got bursts. Otherwise, you'd get super creative for a while, and then you just kind of like ran dry. So the problem with like this robot I'm working on right now is it's like everything I have to do is nothing falls silly side up. It always falls silly side down. And I'm sitting there going like crap. Like today, I I had one of my tasks today was to take 4 wires, ground, VCC, TXTR, okay, and move them over to a plug so that I could plug in my level shifter. I got 2 of them right. I had to, one of them had a bad connection because I had basically soldered to the insulation, and the other one I put on the wrong pin. I mean, it was like, holy crap, you know, this way I'm not going to get anywhere, you know. But you know, you can look on the good side. You know, I found the problems and fixed them and got through it. But I would wish it. Sometimes I wish it was just, you know, like you said, you plug it in and it's rainbows and butterflies. So you plug it in and it goes, oh shit, it doesn't work. Now what? Yeah. So
I will say I had an experience similar to that here this week when I was working on this little board, and I was trying to get a new UART driver to run that little LCD. And so I had ported, of course, all the little code, the little state machine and everything, I ported it over. And then I decided, all right, well, it's late. I'm going to go to bed because I don't want to know that this doesn't work tonight.
yeah.
Because I don't want to be up till 3 in the morning. You know,
Yep.
I'll wait until tomorrow when I'm fresh to find out it doesn't work. So I got up the next morning and I got all day today to debug this and make it work. So I came out here in the garage and I plugged it in and it worked. And I'm like, shit, what will I do for the rest of the day? You know, it blew my whole day.
Blew the whole day.
Well, I do find that sometimes, like I say, when I'm working on a project, I run out of steam. Like I say, you've done everything that you figured out how to do. And now you're looking at the next step, which you're not exactly sure how you're going to do it. And
That's the hardest part.
You know, and so you have to kind of like sit back and think it through and then decide how you're going to do it and then go ahead and do it. So that just happens. You know, if you know what to do, you can just.
Well, there's the whole sitting in the bathtub waiting for the eureka moment too.
Yeah.
My wife designs and makes jewelry, and she's very good with her hands, but she says that the design part is her least favorite part because you don't know where you can go and you don't know what you're going to do. Once you've got the design, then making it, she sits down and she's happy. Actually, I think that's what you're saying. But when she's trying to figure out what she's going to make, she finds that hard and frustrating.
Yeah, and it can be, and it doesn't have to be programming problems. It could be like, okay, I'm wiring up this robot. How do I want to be able to take it apart so that I don't have to unsolder crap? You know, how do I want it to so it looks reasonably neat? You know, it's, you know, what type of plugs I'm going to use. You know, what sort of hardware I'm going to use. Yeah, that's the thing. But I don't know. I think those problems were with me when I was 35. The thing I do notice at this age is that you have patience. Like when I used to work on a car, every bolt was frozen. Everything was right. You know, I never could figure out how to get things off. Nowadays, you know, I just sit back kind of comfortably and say, well, I'll just put some of this on there and let it soak for a bit. You know, I know that, you know, I know the tricks that when I was a young man, I didn't know, you know, or didn't have the patience to do anyway. Even if I knew what I should do, you know, I brute force things. Now I don't do that too much.
Well, Doug, I'm at the age at which you retired now. In fact, I turned 59 this July.
Yeah.
And it's one of these things. My dad retired when he was 55, but there's a huge difference between my dad and I. Is that my dad was a farm boy from central Alberta, and I grew up in the 70s with robots and electronics. And I've got so many things that I want to be doing. But I've got an entire library of books I haven't read. I've got so much that if I retired right now, I'd be really busy. I mean, it would be more a matter of what do I do next? Whereas the problem with my dad, he retired. He worked for Massey Ferguson for his whole career and retired at 55. But the problem was that he didn't have anything to do. He watched television and they traveled a bit.
Okay, no. There's the problem.
Yeah.
I have friends like that too. And the problem is they have no hobbies.
Yeah. He had none.
But I could tell you that before they retired, that they were going to have problems.
Yeah.
I mean, otherwise,
because their work was their hobby, effectively.
Yeah, the work was their hobby, their life.
Yes.
You know, I've got some like you, Murray. I got, you know, I just bought myself a what do they call it, a powder coat gun. You know,
yeah.
learning how to powder coat. You know, and some other stuff. I mean, you know, that's what retirement does. You can say, well, crap, that interests me. I watched this YouTube video and it really interests me. And the stuff doesn't cost that much. I can go do it. I bought some, let me get it right. I think it's magnesium oxide, but I may be off.
For the power coat?
No. This is for parkerizing. So you take phosphoric acid, which you get like for a concrete strip, you can buy it at the home store, and you use this magnesium oxide. You mix into it, you make a solution, and you can parkerize steel. And you know that now you got a trick. You got something in your arsenal that you can.
So it eats away at the mill, then?
No. What it does is it forms a coating on the surface.
On top. Okay.
Now,
right.
And magnesium oxide gives it a better, more even color.
Right. And so
phosphoric acid is what gives the coating.
So because in powder coating, basically what they're doing there is you have a magnet. Basically, you liquefy your metal so that it attracts to the metal, and then
right, electrostatic charge.
Right, and then you heat it up.
And then you heat it up. So you know, I went down to the thrift shop and bought me the biggest $8. Well, it cost me $5 because the woman didn't have the. She said, it's not marked. I'll give you it for $5. But they were normally $8. The biggest oven toaster that I could find.
So you got to use one. Okay, I was curious what type of oven you were going to use.
Something about like this, but you know, it's not your one for toast. It's really for cooking a small chicken. And
really
good for $5, and it works. And so now
you kind of cook the chicken in there too. I wouldn't recommend it.
No. Once you use it for this, it's done. But you know, those are the things. So you know, like, did you get much done? No, because you're playing around with crap that's not related. That's probably another thing. But these are things that interest me. I'm what they call a learner. And that was always my bane at work. Otherwise, a learner, that personality type, loves to learn how to do something, but once he knows how to do it, he's not really very interested in it anymore.
Yeah, you and me are very much alike, Doug. I get
raising hands over here.
I resemble that.
And that's probably what attracts us to this club. You know what I mean? Yeah. You say, well, you can learn robots. Yeah, you can learn robots, but you never finish with them.
No.
You know, and I mean, I look at it. I haven't successfully used LiDAR the way I want to. You know, I haven't made my outdoor rover that can actually go to a cone. I mean, I can go to a cone, but it's not in a controlled manner. I can go to a cone with GPS, but what I really want to do is have the camera drive it to the last 10 feet. You know, that sort of stuff. Anyway.
So, you know, that's really one of the wonderful things about robotics. One of the reasons that I'm attracted to it is because it is this combination of skill sets. So sometimes I'm over there at my lathe and my milling machine, and sometimes I'm writing code. Sometimes I got out my soldering iron. And different problems can be solved in different ways, you know.
Yeah.
So, well, maybe this problem needs to be solved in software, or maybe it's actually easier just to move that sensor to a different location, you know. And I think that also it's what's remarkable about this group is that there's a group of people here who are good at all those things, which is kind of rare to find. You find people who are good at software but can't build anything, and you find people who are those people work well in teams, but they have a hard time just building a robot. But this is a remarkable assembly of people, and this is just the people here today are just a small subset.
Yes, and there are some people they're very diverse in their hobbies. In my case,
that's John.
I'm not Doug. In fact, I do stained glass, I do pottery, I do blacksmithing. Yeah, so
I figured when Doug was talking about powder coating, I thought, oh, that's right down John's alley.
Oh yeah, that was like a year back. So
I have to say one thing, and that is that I was born in Canada and went through the Canadian school system and went through high school in Iowa. And I've long looked back, and I went to California for university, and I've long looked back and figured that it wasn't because I was so brilliant, but I just happened to be born in the right year, because that was pretty much the peak of American civilization in terms of its educational system. The high school I was in Iowa in 1970s was number 2 in the U.S. for SAT scores. And my junior high shop teacher taught wood and metal shop. I had a milling machine in my hands in 8th grade.
Yeah, same here.
And I was not alone. There was a whole generation of students who were learning. I mean, and we even went over to home ec and learned how to cook a chicken that same year.
Okay.
And so think about that, compare it. And this isn't a generational complaint or anything, but if you look at school systems now, we've underfunded them for 2 generations now almost of kids. And so I look back and say, look how fortunate I was to have been in a junior high. I actually go back to my primary school in Canada, where very regimented, and I came out with good algebra skills and good English skills. I go to high school and junior high in Iowa, one of the best places in the country, where I've got shop, and I took 3 years of Latin. And I get to university, and I had the freedom to go through, I think, 5 different major programs. I started in computer engineering and switched to art and switched to computer science, political science, and filmmaking, and got a degree. And I got a career out of that somehow. Now, and I know we're laughing about that, and it is, but you think about that, someone who's 18 right now, it's a bit frightening because the jobs aren't there, the educational system's not there, and it's a whole different world. And we as this group of guys in our 50s and 60s or whatever, we're of a generation where we had that school system, and we were able to take advantage of it. And so, David, you're right. I can run a lot of machinery. I got wood shop equipment downstairs I know how to use. I can use a soldering iron. That's not because I'm so bright. I just happen to be born the right year.
I'll tell you where that system failed me, which was my experience was the same just 10 years before yours, so in the 60s. And when I was in junior high in wood shop learning how to work all that equipment, the women were all over taking typing. I wish I had taken typing.
David,
if I'd known I was going to sit in front of a computer all day long every day for the rest of my life, I would definitely have taken typing.
Yeah, I got a typing class in high school. Yeah.
I got a typing class too.
David, I actually specifically went to typing.
That's for the women, though.
No, it was
not for women.
I saw that this was happening, but I'm probably a few years behind you. I graduated in high school in '69. So
I graduated in '70. So
okay, but I actually at that time. Actually,
I did in '54.
Yeah,
I was too stupid. I wasn't bright enough to see that learning to operate a wood lathe might not be as important. Plus, you got to sit in the class with all the women. I mean,
yeah.
For me, the typing class came about because I had myself a TRS-80 color computer, and I was learning BASIC, and I was learning these things, and I was typing in all this stuff, and I got tired of taking hours to type in, hours to type in a few little things. I'm like, hell, this is a little semester thing. I need a credit anyway, what the heck? Let's go take the thing, right? I type
Well,
like
you were-
crap, but if I wouldn't have had that class, I would not even type as well as I do now. You know.
Yeah, I would take the analogy is when you learn to play a musical instrument, and I recommend to people who ask me if you want to pick up a musical instrument, then go ahead and take a few lessons. So you learn how to learn. Because if you learn wrong, you'll never go back. You'll never go back to the basics and relearn it right. And that's the way I learned to type. You know, I learned wrong. I'm real fast and I'm pretty accurate, but I'm very clumsy. I learned wrong, and I'll never go back and relearn it. But I wish I had. I wish I did.
Yeah, I will tell you the same thing with you guys. Even though I was in high school in '84, I was in 8th grade. I had you know, band saws and doing all these things in wood shop and a little bit of metal work, and they were teaching us some drafting and the whole thing. And then I'd turn around, I'd go to band because I was in band as well. I did that. I sucked at PE though, but that's a whole different story. You know, it's just kind of the way it was. But you know, I just don't get these. I say I don't get these kids these days. That's a Crossy thing. No, I don't get where we basically shunned all the trade skills that everybody that I see on my screen right now has some of those and are able to do all manner of cool things, even if they only had 6 weeks of wood shop somewhere. They've got an idea, and kids don't even have an idea now. They got to call the guys to come over and cut a piece of wood. You know, I'm like,
well, just to bring this full circle in the living room in there, I actually have a pair of candlesticks, wooden candlesticks that I made in junior high school shop. And to bring it full circle, they are coated with linseed oil.
And they haven't gone up in smoke. That's awesome.
Yeah.
Drop it on that one right there, man. Just drop it.
But the
David,
key,
David,
What's that flame showing up behind you there?
but the key thing is, reality is, because I have a nephew, okay? He watches and plays video games, right? Now, in my case, though, for high school, basically I had band, typing, and graphing. So I enjoy building some things, but the key was father really didn't have all the tools I have now. It would have been my mother's father who did more of the tool type stuff.
Yeah.
So I guess I got a little bit of that from there. I really didn't get into all the hobbies I do now until after college, when I had cash, disposable income to buy the tools. So I think part of the problem is that the people don't really realize the tools out there because they haven't been exposed to it. And then the secondary problem is available cash flow.
Yeah.
Don't you think that's why these maker spaces have taken off all over the country?
Oh yeah, that was partially, but the key is you get the people in that have no clue what the bandsaw really was. You know, it's like totally new. Where in my case, because I would go to the library, I would tend to look at books and read books. And, you know, so I had ideas of all the different tools out there before I even got around to playing with the tools.
I know that a few of you mentor a first robotics team around, and I've got one that I mentor as well. And I was just blown away when these guys. I mean, they're high schoolers. They didn't know how to put they didn't know how to chuck up a drill with a bit, a bit and do a chuck, or even put in the battery of a battery operated drill. And like, I do not remember what time it was or where it was. I know I was using the old corded drill, something that I don't know, maybe 6 years old, something with that. I never used one of those.
Yeah, but
I had one of those.
Brace in a bit, I guess.
Things have changed. All right, I had this screw that showed up in my tire about 3 weeks ago, and okay, so I was ready to make the appointment that morning or whatever to go get the tire patched, and I went to drive the truck, and it turned out that it had gone from holding air to being completely flat. So I wound up changing the tire on my truck. It was the first tire I've changed in about 15 years.
They've changed. They're getting.
I had to go to YouTube to figure out where the damn jack was, and then how to figure out how to stick the thing in the end so I could lower the tire.
And the key was finding the slot where to put the jack in.
I could not have changed my tire were it not for YouTube.
What's worse is
what is wrong with this?
Cars, when you go open up the hood where the engine is because you run down the battery for some reason, guess where the battery's not?
Yeah,
they're in the trunk.
It's around Mazda. Yeah, it was in the trunk because there was somebody that had to jump their battery, and we discovered it was in the trunk. So yeah,
that's messed up. All I can say. What's this world coming to?
I don't know.
Kids these days. And I would have gotten away with it too if it hadn't been for you nosy kids.
There we are. Oh my goodness.
I will tell you, gentlemen, I don't mean to be bowing out, but my alarm went off a little while ago. It says I need to start doing some bedtime activities. So
yeah, I got to leave too. Yeah.
I got a 7 a.m., which is 5:30 in Pune, India. So we'll see you later, guys.
Yeah.
Have a good night.
Take care.
Take care.
Where's the button? There it is. Stop.